Okay, so this is now being recorded. So hello, good afternoon, good morning, everybody. What follows is a brief overview of PCB estimation within SEER for manufacturing. If there are any questions at the end of this, you all have my contact details, Steve Robinson, srobinson@galarath.com. Please feel free to send any questions through. Keith is going to provide an overview of the capabilities of the tool and the information that is available from it, and then we can move forward from there. So Keith, sir, over to you.
Okay, thank you, Steve. So what you see on the screen at present is SEER for manufacturing. SEER has many processes, of which PCB manufacture is just one of them. And as you can see from the drop-down list, we do machining, fabrication, electrical assembly, a variety of aero operations, composites, curing, trimming, etc. Today, we're focusing on PCB and how SEER for manufacturing caters for both the manufacture of the board and the population of the assembly of that board, its testing right the way through, so we can get a full bona fide estimate for a PCB. So like all of our tools, we have a variety of tabs: our tooling, inspection, part mark, and general. They are common across all the processes. So in the general tab, we're going to tell the model how many we're going to produce, what size batches we'll be running at, the labor rate. Now this can be in a variety of currencies, so we can work in dollars and sterlings and pretty well anywhere else around the world by setting that up in the options dialog box. We tell the model how good we are, and the classification of the part, which we can see is, in this case, designed for high reliability applications, aircraft, military space, etc. If you wanted to produce commercial boards, then you would come down lower, and that would just detune the model in accordance with the requirements and rigor associated with that development standard. So in this case, we're making 2,000 boards in batches of 200. We've made 1,000 boards before, and we're going to stop our learning at the 96th percentile, so we can include learning or not, as the case may be. We do Rawford and Cruyt, cumulative average, and unit learning. So if you're in a very high volume production, commercial, washing machines, for example, then learning curve is probably not a consideration, but within aerospace and defense, learning is a real consideration that needs to be done because of the low quantities. So the process specific tab itself, in this case, we have part of our 4-pane configuration. The top left-hand side is where we put the work elements. This is the operational sequence that will turn our substrate into a board and the components onto that board as part of the process. It can be many levels of indentation. You can do what-if scenarios, you can set references, trade studies, etc. within SEER for manufacturing. For every line item we have in the work element window, we have a corresponding set of parameters associated with that. And each one of these will help give the model some outputs. So at the bottom, we have model outputs, reports and charts showing us our direct minutes, our setup minutes, inspection, rework, and tooling if we so decide to include tooling on that. So the process specific, where the work is done for the boards, so the windows can be resized and manipulated as required. We have basic board and detailed board, so I'm just going to consider detailed board to start with because it's more complete. It shows you at high detail how deep we go within the process for the manufacturing of the board. So we simply say yes, no to turn these on or off. And in this case, we're saying yes, and we know the board length, the board width, which are user inputs. This is using local defined inputs. So this is another new addition to SEER MFG version 8, where we can have global and user defined parameters where we can drive other algorithms and other costs out of the model based upon our own internal efficiencies, inefficiencies, state-of-the-art processes, obsolete processes, whatever it needs to be, you can take control of the model if you so desire to do additional algorithms tuning as well. So if I look on this one, it's using the expression editor and it's putting in the names and the lengths, etc. So these are going to be straightforward inputs. We can take that straight from the drawing. Gaps between the rows, gaps between the columns, consumptive layer count, and these are calculated from all of the inputs above. So these are calculated. The board area is a function of the size, obviously, and its yield is a 91.91%. So it's quite an efficient process. So the board itself down here is length and width. We have 4 rows and 4 columns per panel. Now these are calculated based on the expression editor, which somebody has put some work into, some previous thought to do with nestings and gaps and PC boards and columns. So you can see the amount of detail you can break this down to if you so need to. The useful percentage of the board area between 75, 80 and 85, and at this point I'll explain to you the 3 inputs. We have a least, a likely and a most. So it allows us to capture uncertainty in the process. So we don't know how much of this board is actually going to be used and utilized. So most likely is 80. The most it could possibly be is 85, and we think 75 is a reasonable lower end of this range. The model takes a PERT mean. It takes 4 of the likely, 1 of the most, 1 of the least, and divides that figure by 6, and that's what goes forward into the algorithm for manipulation by the mathematics in the background. The board material is a growing list. You have the capability of adding your own materials, your own board substrates. We have these here, which are obviously current for today's PCB manufacturer world. I won't add any more. We have 2 in there already. We have a B stage prepreg. It's cost 1 layer and 2 layers of C stage copper board substrate here as well. Utilization factor is 1, so we're not wasting any of the board. So we've got a nice straight rectangular board maybe. And then all of these operations you can add or you can save as a knowledge base, so that it is pre-canned and ready for use for your current board manufacturing process. So as you can see, this one is preparing the materials under kitting, and under that option we have a wide variety of options, and we'll look at some of these in a second just to let you know the level of detail that we're going down to. The next operation is panel cutting. So we have scoring, milling, routing, sawing, shearing, hand power tools, etc. Next one in the list is we're doing some drilling using carbide, 4 holes, diameter 1/4 of an inch, and you can work in imperial or metric. The model works in both measurement schemes. Next, more drilling. We're now doing some bare board testing. We're just inspecting the hose, inspection interval, support factor, operation quantity 4. A little bit of plating, so we're doing some electrolysis. We could do electroplating, immersion, hot air, leveling, 1-step whole wall activate, selective brush, or selective finger. So we'll click out of that one, and each one will depend, and we'll tell it the surface area that's, in this case, having copper strike. The support factor is the amount of time the operator will be present during the process, and they're doing them one at a time. The plating type is copper, but it could be gold, nickel, silver, tin, or zinc. Doing them in batches of 24. We're putting in 985 microns of material, and material cost comes in from the INI file, again, which you can add your own plating materials if you so wish. I'll come out of this one, and it goes all the way through, inspecting the hose, cleaning it, apply resist, expose the resist, develop the resist, and it's a lot of operations to make a board. This is reality. In reality, you can capture, you can save this and save it as a knowledge base, so that once you set it up once, you will use this common process every time for your board. Here we can control the level of mechanization. So is this an automated process, high volume, robotic, multi-spindle drillings, multi-board etched, etc.? Or is this going to be very manual, very mandrolic at the low end? So we have that control there also. So that gives us our manufacture of the board. We have reports. So if we right click, choose available reports, we can look at the inputs. So we have a variety of reports available. If we're working in multiple currencies, we're doing production lots, inputs, reference, sensitivity, etc. So we'll look at the detailed operation details, and we can see all of the time broken down, infinite detail, where you can go, this is correct, any one big. So we can look for the large ones. These are 6%, some secondary drilling. Can we improve that process? Can we make this better? So we have a lot of information here for every one of those processes that have been painstakingly put in place, ready for this board estimate. So we're happy with that. And then at this stage, you have the option to assemble it, add the components. In this instance, they've been put in for clarity into a second one. So in this case, we're not making the board. We're just going to assemble this one. Detail PC board, yes. So this now is another list of operations for the assembly of all of the components onto that board. So we're going to kit it. We're going to solder paste print some of the board. We're going to auto place 40 of the components, some odd form soldering, part of the component placing again, all the way down through manually attached fasteners and screws, 4 of these, hand soldered joints, 5 of them, coaxial connections, heat shrink. So this is a fictitious board. This doesn't reflect necessarily reality. In many cases, you would have less operations because you wouldn't have all the scenarios added to the board. It's a simple process. Double click add operation next. We can select the process. We can put a coating on. We could say where it's a conformal coating. And this operation has a setup, a load and unload, and we add it to the list, and there it appears here. I'll just delete that one. So you can add and delete. You can copy and insert paste or paste the processes. So a lot of these replicate themselves, like test operations here. You could do it once, copy it in, and speed up the process. Down further, we have the components. Now, adding the components can be done manually. You can take information from SAP, place it either via middleware into SEER, or most commonly people will take it from SAP into Excel. They can then put it in the correct format that SEER will recognize, and then it will paste it into the model here, such as this. Now, if I take this as a list, and copy it, I can bring it into this one here and paste it, and you'll see we have a command line listing the components, what type of component is it, a description, quantity, cost, and that can be taken into SEER. If I come back to this one here, and I come back to my top, just to emphasize what you can do, I can take this and I can delete all of the parts from within it. And assuming we've just pulled the BOM in from SAP, we've manipulated it into the structure that we need, we can simply copy that, come back to our estimate, and we don't have to be on the right place. We can just paste it, and it will put them in the right section again at the bottom, ready to go, pre-costed. We also have a catalog functionality. We can add an X component here. This is where we would manually add it, select the type, an ASIC maybe, which we can estimate in our SEER for hardware model, which will be part of another demonstration. Quantity 1, and we'll say this is £250, click on OK. We can use the catalogue where we can look at our PCB components, and you might recognize these. Some of these I just entered earlier, so we can take that one, click on OK, click on OK. Oh, I didn't add the quantity, sorry. We'll do that again. Search the catalogue, PCB components, off-the-shelf IC, OK. This time we'll have 3 of them. Click on OK, and we have that in our BOM at the same time. So, like I said, there's a lot of work. We've done it in 2 operations here. Now, I also mentioned that to save having to redo this process for this one, for the manufacture of the board, and for this one, the fitting of the components, we can save and create knowledge bases. The knowledge base saving is a straightforward process. You simply get something correct, file, save as a knowledge base template, and it would then become available for saving as an available setting of a process for yourself. So I combined these 2 together. So I'll insert a new PCB. I'm going to choose my PCB detailed fabrication and assembly knowledge base. Click on OK. And this now has all of our predefined inputs at the top. This has notes in this one telling us to enter the board length and width. I've highlighted it to be red to bring attention to it. So I'm going to make it 12 inches by 9. Click on OK. We come down. We don't need to worry about the process for the manufacture of the board. That's already been done. All we might need to do is critique it, maybe saying we won't have any chamfers, so we can delete that one up, and all of a sudden we're now ready to do all the rest. The assembly is done, so we know the process of assembling all of the parts. All we'd have to do is critique the values to match the components being fitted to the board. And as for the components, I saved it with the ones in previously. In reality, you would probably not save them as part of the knowledge base, but you would copy them in from SAP, from Excel, wherever the source of your data was, or you can build that manually from the catalog. So that, in a nutshell, is how SEER for Manufacturing handles and caters for PCBs. I hope you found it informative. Like Stephen said, any questions, please contact him at srobinson@gallerith.com, and I'll just pass you back to Steve. Thank you.
Perfect. Thank you very much, Keith. Hopefully, as I said, that's a general overview of the capabilities, and Keith has done an excellent job of highlighting all the various bits and pieces that are available within the PCB estimation environment. Thank you very much, Keith, and thank you everybody else for your time. Very much appreciated.
Welcome.